So one of the things we talked a lot during our trainings is taking images in an overlapping manner. In other words, taking overlapping images so it will work in photogrammetry, so it will work in structure from motion. So I would like to show some of the examples to make it a little bit more clearer to our colleagues. So to start with, if we imagine a point on the surface, it can be on the ground, it can be on the wall, it can be on the object, then in order to have this point mapped in three-dimensional environment or 2.5 dimensional environment, we need more than one camera covering it. So in this case, for example, two cameras covering that image. We ideally want more than two cameras. We want three, four, five cameras to get a proper position of that point. So if you put it under this angle, then you can see two camera positions, and software ultimately will calculate it as in a triangle, the angles and the distances between two cameras, and then calculate the location of the point. This will work particularly well if we were taking aerial pictures with our unmanned aerial vehicles from above. But the same principle usually applies when we take ground-based images or images of the objects as well. So this is the example I used previously. Let's imagine that this is a wall of the building, and if we wanted to map this wall and create orthomosaic, then my approach to that will be taking pictures in this manner. We'll start from here, first camera here, and then second image, third image, fourth image, fifth image, sixth, seventh, eighth. So as you can see, there will be a lot of overlap, cameras following each other, and about 60% overlap in this case between this camera, and this will give us a very good coverage, very good overlap. But as you can see, this is only the top part of the wall, and I would usually divide it into two areas and take the same number of pictures in overlapping manner, at the lower level as well. These images will not only overlap each other, but they will also overlap with two different levels of the picture taking. As a result, we'll have a very good model of the any given wall. So I have some examples for you, but most often, in order to make the pictures visible, we will also take some general pictures like these ones, so they will actually help us understand where our smaller images are located. So let's go to some of the examples from the walls. So this is the wall of Juncker, and you, the colleagues from our project, you actually took these pictures. These are not my pictures, and as a result, we created a very good model of that wall. You can see individual images here, and then when they add up together, they create this type of a model. So if we look at this model, and if I enable the cameras from here, you can see a row of cameras taking loads of overlapping images. There is a clear line going from above and going from below, although distances are quite different from picture to picture, but nevertheless our model works out really well. If I say show thumbnails, then you can actually see individual pictures how they looked when they were taken. So let's disable these cameras for now, and in most cases you will not have enough time on the field to process everything to this stage and to check that the pictures are overlapping very well and your model is very good. Uh, Instead, what you will have time for is actually creating a quick tie point, so something like this one, for example, in this model. And that's okay. If you can create it in a very, very low quality on the field, then you can actually check your overlap by using a very simple function in Photoscan called generating report. So if I click at this stage, generate report. So this is obviously um, Juncker, and if I say this says from top, but it doesn't really matter. I don't remember which view this was. Let me check that. This is yes. This is currently computer sees it as top. That's fine. So if we say generate report for Juncker, if I say OK, it will ask me to save it somewhere, so I'll just say report here and save it. So once the report is saved, then we can see it here. This is our wall, and this is a very important part of it. Here you can actually see sections of the wall covered with overlapping cameras. So these black dots where our cameras are located. So as you can see, one line going from above, one line going from below, and some pictures in the middle taken. But the blue color here, as you can see from this area, means that more than 9 camera angles cover that section of the wall. That means our model will work out really nicely. There will be no errors, no problems with ultimate model. And there are camera calibrations here, and you can see this from the result here. It's a really nice looking wall, all the heights reflected accordingly, and when the DEM was created, it actually reflects that, and also mosaic as well reflects that really well. In addition, I have some other examples. For example, this is the same wall taken by another group. Here, it doesn't go to 3D model stage that yet. This is just simply testing out the results on the field. And here, similarly, if I enable the cameras, you can see how the cameras are located. They're in a really nice row, um, going along the wall and documenting the wall very nicely. But as you can see, the distances are not always universally correct. So it will be better if the cameras were following this way, keeping the same distance from the wall. But nevertheless, it works out really nicely. So if I were to create a model from this one, let's see how it will look. Here again, Juncker 2. So let's go. So um, this report looks like this here. Yeah. So as you can see, because there is only one line of cameras, the area with blue, 9 cameras or more, is limited. But that's not a problem as long as we don't have, for example, the two, this orangey color, or three. We have three somewhere in these areas. It's not a problem. Usually three is okay, but two will be very, very difficult. If we have only 2 cameras covering the point, then that will probably be discarded. You can play with the settings in the software and then make them work as well, but it will not be very accurate. So we would like to take more pictures to see that more clearly. I have other reports similarly from other processings that were created using the similar pictures from uh, your exercise there. So this is a very good example where pictures were taken following two heights, two levels of picture taking. But as you can see, in some sections of the wall, there is a lot of overlap, but in other sections of the wall, there is not enough overlap. And you can easily see the reason for that, because in this area there are 3 cameras, 3 cameras, 2 cameras, and they're very close to each other. But in this area, they're very random, and the distances between the camera positions are quite far apart. So that's why it simply doesn't work. The red color there means it will probably not work. The same is actually true when it comes to the objects as well. This is our favorite object from Sfax Museum, which we all modeled together, and the model looks very nice. And if I enable the camera positions around it, you can see how they nicely overlap with each other, and how many different angles do they actually cover. And that then enables us to create a really nice model that we have here. So here as well, if I were to enable the thumbnail of the cameras, you can see how the different pictures will look. And also if I was to enable this option here, for example, you can actually see how different cameras will look in reality. So let me disable that, and let me also disable this, just to show again how the overlap here matters a lot to create a very nice object model. It's often more difficult to achieve good overlap with small objects. With something like a big wall, it's reasonably straightforward, and you can pace yourself, measure distances, and find the perfect camera positions. With small objects like that, it's often a lot more difficult to do, but it is possible. And I would like to show maybe this object here as well. It's a very nice jar, and as you can see, the model looks very nice. And if I enable the cameras, you can see how the camera angles worked here. I took it myself. This is not from North African region is from Central Asia. But as you can see, the cameras follow each other very nicely, and as a result, it achieves a very good overlap, and our model works out very nicely too. So this is basically it about the overlap, but we'll come back to the same point during our future trainings as well. Thanks so much.